This is page 52. Electromagnetic effect. Draw a circuit symbol for a diode. So what is the circuit symbol for a diode? I think we discussed this.
Yes, sir.
63? Okay. Electromagnetic effect. A permanent magnet is made from only one material. A permanent magnet is underlying a material which is possible to make a permanent magnet. Aluminium, it's a non-magnetic material. Copper, a non-magnetic. Iron is a magnetic, but it is not a permanent, it's a temporary. Non-magnetic, non-magnetic, non-magnetic. Steel is a magnetic and it's used to make permanent. If it was a temporary magnet, then we will underline.
So what is soft iron used to make for?
It is used as a core of electromagnets, or it is also used in a transformer.
For you write core of magnets, right?
Electromagnets.
Electromagnets.
Yes.
When I was in Egypt, only we took like
Yeah.
that's it.
This is classified paper 4, electricity and magnetism. An electron source produces a narrow beam of electrons that all travel at the same speed. An electron source is placed in a vacuum and the beam of electron travel vertically downward. The beam of electron before it passes between the north and the south pole is shown. Describe what is meant by direction of a magnetic field and state the direction of a magnetic field between the two poles. What is the meaning of direction? What is the meaning of direction of magnetic field? Direction of a magnetic field, yes.
Three lines go.
Direction of a magnetic field is a direction of the force. Direction of force on. No, the question is magnetic. Direction of force on north pole.
So why not field?
No, the question is state the direction of a magnetic field. What is the meaning of a direction of a magnetic field? Direction of a magnetic field means the direction in which the north pole will move. Like if I place a north pole here, where it will move? It will move in this direction. So direction of a magnetic field is always the direction where north pole experience a force. Same thing if they ask what is the direction of electric field, then you will say it's a direction of the force on specifically positive charge. Like where the positive charge experience force, that is the direction of electric field. Where north pole experience the force, that is the direction of magnetic field. 63. So what is meant by the direction of magnetic field? So we will write here, it is direction of the force on, direction of the force on north pole, and state the direction of a magnetic field. So it's direction from north to south, or in this case it is towards right. Yeah, left to right. Because it's from north pole is on the left hand side and the south pole is on the right hand side. So the direction is from north to south. Next is describe and explain what happened to the beam of electron in a magnetic field between the poles. Whenever a charged particle is moving perpendicular, look, whenever there is a charged particle and it is moving 90 degree or perpendicular to the magnetic field, what will happen? It will change in direction, or we use the term deflect. Yeah. But where it will deflect? For which rule you have to use? Because it's a negative particle. Which rule? Right or left? Left. No. Right. You can use right, but then you have to make it opposite, because you can use left. Yeah. If you're, for example, if a beam of electron is there, we are using, the rule is left hand rule, but we make it opposite for the negative particle. Yeah. So the rule, because a standard rule is a left-hand rule. But for an example, I said instead of using it for a negative particle, instead of using your left hand, you will use a right hand to get the direction. But when you state the rule, you will say it's a left-hand rule. Okay? Because the negative particles will move in opposite direction. So for working out the direction, you can use your right hand. But the rule, the standard rule is a left. So let's say, or if you are using a left-hand rule, negative particle will move in opposite direction. Your index finger represents the direction of a magnetic field. So where your index finger will point? So your index finger is pointing towards south, so it is on the right-hand side. Your first finger or index finger is pointing in the direction of a south. So your index finger is pointing on the right-hand side. Your second finger represents the direction of the particle where it is moving down. So your second finger, your index finger is pointing towards right. Your second finger is pointing down. Where your thumb is pointing? No, thumb is pointing towards you. So thumb is pointing towards you. It means if it's a positive particle, it will move towards you, out of the screen. But because it's a negative particle, so where it will move? It will move away or into the screen. Your index finger into and out means related to the screen. If it's pointing towards you, it is out. If it is going towards the screen, it is in. So when I apply the rule, look, when I apply the rule, index finger is pointing towards south. Index finger is pointing towards south. Second is representing the direction of the particle. Where the thumb is pointing? Towards you. So this is called out of the page. When it is thumb is pointing towards you, it's out of the page. So if it's a negative, if it's a positive particle, it should go out of the page. But because it's a negative particle, so it should go into the page. If you use a left hand, just inverse the direction. Or if you use a right hand, you will get the same direction. So how to describe and explain?
Sir didn't see him since 2 weeks. Sir, how are you?
Yeah, last week I have seen him.
Already?
Yes.
Sir, 7 days. You know how much hours? 8 days. 24 hours into 8, how much?
Okay.
24 hours into 8 into 6.
The motion, force, and direction of the magnetic field.
Yeah, the particle moves perpendicular or 90-degree to the magnetic field. So the particle is moving 90-degree or perpendicular to the direction of a magnetic field. It experiences a force where it will experience the force into the page. And the third point, it will move perpendicular, or you can also say in a curved path. So always this should be a structure of an answer whenever you explain the direction of the particle in a magnetic field. One is first the particle is moving perpendicular to magnetic field. That's the first point. The second thing, you will write which direction it will deflect, either in or out or up or down, like top of the page. These are the 4 possibilities. And the third point, you will always mention it will move in a circular path or a curved path, because the force is always towards the center.
There is a source of
A beam consists of alpha, beta, and gamma radiations. So we have alpha, beta, and gamma. Explain how a uniform magnetic field may be used to separate alpha, beta, and gamma. How we can use? First thing, what we will do, we'll apply a magnetic field perpendicular to the direction of the motion. Like let's say this is a region of a magnetic field. this magnetic field, I'll write the answer as well, but this is an explanation from diagram. When I put crosses, it means magnetic field is into when I put the crosses. Okay. So the particles alpha, beta, and gamma, all these particles move perpendicular to the magnetic field. When they will move perpendicular to the magnetic field, how we know it's a gamma? It won't deflect. The radiation which does not deflect is gamma. The radiation which will deflect less will be alpha. And the radiation will deflect more will be beta or electron. And it will be in opposite direction. So how the uniform magnetic field may be used to separate alpha, beta, and gamma. So we apply a uniform magnetic field perpendicular to the direction of these particles and radiation. If gamma won't deflect, beta will deflect the most, and alpha deflect the least in opposite direction.
Can you show the hand rule in the
If I want to use a hand rule, I will use the left hand. I'll use the left hand. My index finger is pointing into. The second finger represents the direction of the particle. Where thumb is pointing, it's pointing up. So if it's an alpha, positive particle will go up and beta will go in opposite direction. So there are two ways to understand this. You apply left hand for every particle. If it's a negative particle, just change the direction. That is one way. Or second rule is you use for positive particle, you use left hand, or negative particle, you use a right hand. So it's up to you which one you remember. If you remember only left hand, just try to remember that positive particle will follow the left hand and negative particle will be opposite of the left hand. Or you can use for positive left hand and negative you can use right hand. If you use an electric field, then what will happen? The electric field, if they state how electric field can be used to show the deflection of these particles. So we set up the electric field. Alpha particles, again the perpendicular. Alpha particles are positive, so they will be deflected towards negative. Beta particles are negative, so they will be deflected towards positive. And gamma will not deflect. And again, the deflection for alpha will be small as compared to that of beta. No, I showed here that it starts to deflect from the beginning. No, in the electric field, no hand rule.